Okay, today we're going to talk about the nature of decision making based on sampling. So this is something that you might see in the quality field, although there are applications to other fields as well. But the basic premise is that you've got a process that's manufacturing something or providing a service, and it's got a kind of an actual but unknown state that it's operating in. Okay, it's either operating really well or it's not operating well at all. And as a decision maker, you want to understand, how that product is being manufactured. So there's an actual but unknown state of nature in which, let's say, the product is either good or defective. You're going to pull a sample from that process and you're going to make a decision about it. And you're going to subject the product to certain tests, maybe look for defectives and so forth. And typically there's a threshold value. So it's usually designated by the letter C. So if you look at acceptance tables like in Mill Standards or some textbooks, they provide this threshold value. And let's say the amount of defectives is below this certain threshold, and you can say that the product is truly good. Okay, if it's above a threshold, then you say the product is defective. Now, if you make the assessment that the product is good and the true state of nature is that it really is good, then you've made a correct decision. Okay, and your confidence will be 1 minus alpha. So alpha here is your risk that you're willing to take that will be incorporated in your sampling plan. So there's always variability in systems. Okay, there's always a level of risk. You can't sample everything. And you're doing kind of an inspection here, so there's a lot of factors that can affect the risk. But let's say you accept 5%. So then your confidence that you've made a correct decision is 95%. Now keep in mind that confidence is a statistical term here related to estimating a parameter like percent defectives. And a lot of times people confuse confidence with a psychological idea of, well, I just feel 95% good about something. Okay, so it's really not about that. It's more about how well you can capture what's really going on here. On the other hand, if you say that your product is defective, okay, and the product is really good, okay, that's going to be called a type 1 error. And that's the alpha level. And it's also called producer's risk. So the problem with this is if you're saying product is defective but it's really good, you can end up holding product you don't need to. You can shut down a process and so forth. So there's a lot of problems when you're making an incorrect decision related to if it's defective but it's truly good. However, if it's good and you've said it's defective, okay, this is called a type 2 error, and it's designated by this beta risk. Okay, here you're going to be releasing product that is defective, and obviously the problem here could be high consumer complaints and a host of other issues. And then the last situation is if you say a product is defective and it truly is defective, then you've made a correct decision. Okay, and that's called your power. Okay, so typically when you're developing a sampling plan, you can look up your alpha and beta levels, and there are tables that are published for this. And if you're using Minitab, you can actually create your own tables as well. But the whole point here is trying to make a good decision that reflects the reality, knowing that there's always variability in inspection and in the process, dimensions, data, and so forth. And you're trying to minimize that error as best you can. Keep in mind a lot of these, where you try to maximize your confidence can result sometimes in a larger sample size. So you have to be kind of careful. So it's really a matter of balancing, economics with the risk as well. But essentially, that's kind of the basics of sampling. And again, there's a lot more information out there how this works more specifically. Hope this helps, and we'll talk to you again.